Okay, we're told the velocity is 40 in the first hour, and velocity follows this speed pattern after the first hour. So we need to sketch it. So because I've got a digital pen, I'm not going to worry about using a ruler, which is what you should use. First of all, it's 40 in the first hour. So it's a digital pen, so I'm just doing dashed lines here. And then it follows this e to the minus t over 2. When t is 1, you get 40 e to the minus 1. Okay, so but this is for the second hour. It starts, so we reset the clock here, basically. So we're resetting the clock here. So when you put 0 in, when you put 0 in here, you get 40. You see, so it slows down. So it's as though we're drawing this curve, not from here, but from here. So I hope you can see that the way the wording of the question is explained. So in actual fact, that curve on this graph won't be this, will it? The function, it'll be 40 e. Well, we could draw another axis here actually. So let's draw another axis and have a new curve. We'll call this y dashed, and we'll call this x, and we'll call it x dashed. Okay, so we've still got our y dashed. So this is v dashed then, we'll call it, and this is v, and this is v dashed. Okay, so we can start from 0 again because we've done a new axis here. It's just areas under curves anyway. So there's the sketch. And then, so we've got that. Region of distance covered in, what was it? In the second hour of the cyclist ride. Well, the second hour would be here, wouldn't it? There. And this would be second hour. Distance. How far in the second hour and total distance? Well, how far in the second hour would be this area. So area A. So the area A is equal to the integral between naughts, and it just goes on to infinity. With the second hour, so it'd be, we're using the reset clock, so it'd be from 0 to 1, because we're starting the reset clock here. And it's 40 e to the minus t over 2 dt. Hope you can see that, because we're using the reset arrangement. So that's the area under that curve. So e to the minus t over 2, integrate that. E to the minus t over 2 divided by, how many t's have we got? We've got minus a half, so we divide by minus a half. That's the rule. Remember, the integral of e to the ax is e to the x over a, the number of x's, so the number of t is minus a half. So we put that underneath. And that's between 0 and 1. So that's equal to, move the 2 up, it's minus 80 e to the minus t over 2 between 1 and 0. Top value, take bottom value. Hopefully it comes out positive. So we've got minus 80 e to the minus a half, minus, put 0 in, e to 0 is 1, minus 80. So it comes out as double minus is plus, so write that term first. Half, and that's just 81 minus e to the minus a half, isn't it? Take the 80 out as common. So tap that in the calculator then. 80 times bracket 1 minus e to the minus half. There we are. Close that bracket. 31.477, so that's 31.48. And the distance, hours and kilometers per hour, isn't it? So it's kilometers is the unit of distance. So that was that. Now that was the first part, the second hour. Now this area here, we could work it out by integration, but because it's a rectangle, we can just work out the area of the rectangle. It's 40 high and 1 unit long. So the area is 40. Total is 40 plus 31.48, which is 71.48 kilometers. Okay, now part D. How long for 100 kilometers? Well, how far has he travelled here? He's travelled 40 kilometers, wasn't it? So it needs 60 kilometers more in this section. So that area here must be 60. So the area is 60 is equal to the integral from 1 to, we don't know what this is, so I'm going to call it b of 40 e to the minus t over 2, wasn't it? dt. We could call it y if you want, but we've used x's and y's, so let's just call it b. We know this first value is 1. So this area is 60, isn't it? Because the initial speed was 40. So 40 e to the minus t over 2 over a half minus a half. We've done that before. So that comes out minus 80, doesn't it? We've done this integral before. And that was between b and 1. So 60 is equal to minus 80 e to the minus b over 2. Top value. Take away bottom value. E to the minus a half. That's what we got. So a bit of algebra now. So this is a plus, so move this over. Oh, move this over first. That's best. Then you get 80 e to the minus b over 2 is equal to, and this is plus, e to the minus a half. So that's a plus, and then move the minus 60 to be with it. Then divide by 80. 80 minus 80 e to the minus a half minus 60 over 80. And that's that. Then take the logs. So minus b over 2 is equal to log. So I'm dropping this down and writing the log form. 80 e to the minus 1 half minus 60 over 80. And then we need to just find out b. So b will equal, so this minus I'm going to take over, and I'm going to take the 2 over half to 2, and the minus can come over. And then 80 e to the minus a half minus a 60 over 80. And I'll put b in here, squeeze it in at the bottom. So let's get that then. Minus 2 times log brackets 80 top value, so I'm going to put another bracket now. 80 times e to the minus a half, I'm going to put 0.5 minus 60 on top, close that bracket on top, divide by 80 underneath, close the log bracket. Let's have a look what's wrong here. I've put 2 brackets at the front. I've got answer, I don't want the ants. Just minus 2 times log, and I put 2 brackets, one for the top. 80 minus 60 divided by 80, close that bracket. Yeah, I must have another bracket needed or something, I think. No, so let's see what's wrong with it then. I'm going to get rid of that minus because I know it's negative. 2 times log of bracket 80 e to the minus 0.5 minus 60 close bracket divided by 80 close bracket. I think that should do. Equals. Funny, isn't it? Oh, it must be a negative number. It's not working out the log of that. So let's have a look where I've gone wrong. Let's see where I've gone wrong. 60 is equal to this. Yes, I can see where I've gone wrong, because 60, remember the reset of the graph? So that isn't 1, it's the reset time. We reset the clock at 0 there, didn't we? So it would be 0, so this would be 80 here. So that makes it a bit easier. So it would be 80 this, minus 60 is 20. So that's just 20, I'll put that in straight away. And this would be 20. And 20 over 80 is a quarter, isn't it? Is equal to 1/4. So we've got a simple little calculation to do now, so let's just tidy that up. Get rid of all this. Minus b over 2, and then we can write the log form. Apologies for that, but let's just make the correction now. It's good to see the error in practice. So it's ln1/4. That tells us what b is. Minus can come over and the 2 can come up. Minus 2 ln1/4. So it's minus 2 times natural logarithm of 1/4. Oh, minus 2. I'll get it right in a minute now. Natural logarithm of 1/4. There we are. 2.77. So that was 2.77. But that's the second time, isn't it? In the second quadrant, the second area, to get the 60. But you've already spent an hour to get the 40 done. So answer is equal to, add 1 to this, 3.77 hours. Easy to make a mistake on that one there, as I've illustrated quite well.